some of the properties. We are going to learn about inverse and adjoint. Now we have learnt minors and cofactors in the previous exercise. If I know the cofactor matrix, transpose it, I call it as adjoint. This adjoint helps us in finding A inverse. Why should I learn the inverse of a matrix? Now in matrices we have learnt addition is possible, subtraction is possible, even multiplication is possible. Now the question is division of matrix possible? The answer is no. We do not have division. Instead, we have the inverse operation. So, inverse operation is an alternative for division. A by B or B by A is there. I do not allow this. This by A, I write A inverse B. So, instead of writing B by A, we write it as A inverse B. How to find this inverse? And here we have the formula 1 by determinant A adjoint A. What is adjoint? A cofactor transpose. Now exercise, we will be doing problems based on these formula. Suppose determinant is 0. Can I find A inverse? What is A inverse? 1 by determinant A. 0 should not come in the denominator. So whenever I write A inverse, I will say determinant A, that which comes in the denominator, should not become 0. Determinant A 0 implies the matrix is singular. Determinant A not equal to 0 implies the matrix is non-singular. So inverse exists only for non-singular matrices. That is, determinant A should not be equal to 0 and then I can find A inverse. What are some properties of adjoint? Now these are important for one-word answers. Most of the objective questions come under this formula. Determinant of adjoint A is determinant of A the whole power n minus 1, where n is the number of rows or columns in A. N is the order of A, we say. Determinant Ka equals k power n determinant A. Notice the two things. In adjoint, we say determinant A power n minus 1. In determinant Ka, we say k power n determinant A. And adjoint of Ka, I must link both. It is k power n minus 1 adjoint of A. A into adjoint into A should give me determinant A into In. Adjoint of AB, reverse and write the formula. First we write adjoint of B and then we write adjoint of A. The same thing we use in determinant AB. Determinant AB can be written as determinant A into determinant B. We had done a problem in the previous exercise. But when I come to AB the whole inverse, this property only I use here. It is B inverse, A inverse. Now some of the properties of A inverse. Whenever A square is I, how do you find A square? A into A. If A square is I, we get A equals A inverse. And whenever I multiply A and A inverse we actually said for 1 by A. We don't write 1 by A, instead we write A inverse. So A and A inverse will get cancelled, giving me only I. So A inverse or A inverse A, however I multiply, I must get I, a very important property. Now adjoint of I is the unit matrix. The name itself tells me I into I is I square, I cube, I power 4, any power is I. Adjoint of I is also I inverse is also I, and that's why the name unit matrix. So we have certain formula, and all these will come under objective type questions. For exercise for 2 or 3 marks, we mainly use this formula, and let us be thorough with the method of doing this. A inverse equals 1 by determinant A adjoint of A, provided determinant A is not equal to 0. Let us continue with the exercise. Exercise 1.2, question number 1. Find the adjoint of the matrix A equals 2, 3, 1, 4. Writing adjoint of 2 by 2 matrix is a very simple procedure. Interchange the main diagonal. So I write 4, 2. What do we do? For adjoint of 2 rows and 2 columns. So I write 2 by 2 matrix. Interchange main diagonal elements. That is my first idea. Interchange main diagonal elements. The other diagonal, change the signs. So 3, 1 I write as it is, but changing the symbol. -3, -1. So writing adjoint for a 2 by 2 matrix in just 2 steps. Main diagonal 2, 4, interchange. I write 4, 2. The other diagonal, change the symbol. So +3 +1 will now become -3, -1. Question number 3. Find the inverse of. Whatever matrix they have given, call it as A. 1, -1, 2, 3. Whenever they ask you inverse, find the determinant. What is the determinant? Multiply 1 into 3 minus, multiply these two. 2 into -1. Simplify the answer. 3 minus of minus is +2, which is 5. Determinant A not equal to 0 implies A inverse exists. The next step, find out adjoint of A. For a 2 by 2 matrix, we have a simple procedure, interchange. 1, 3 will now become 3, 1. Change the symbol. 1 -2. Now I know the determinant value, I know the adjoint. What is the formula for A inverse? 1 by determinant A, adjoint of A. My question is to find inverse. 1 by determinant A is 5, adjoint is 3, 1, -2, 1, and that is the answer. Second subsection, find the inverse of 3, 1, -1, 3. Treat the given matrix as A. A equals 3, 1, -1, 3. To find inverse, the first step is to find determinant. Determinant 3, 1, -1, 3 equals 3 3s are 9 minus -1 into 1 -1. Minus of minus is plus. 9 plus 1 equals to 10. Determinant A not equals to 0 implies A inverse exists. The next step is to write the adjoint. How to write the adjoint? Interchange the main diagonal. 3, 3. The other diagonal, change the symbol. +1 will become -1. -1 will become +1. So writing adjoint, interchange the main diagonal, change the sign of the other diagonal. and A inverse is 1 by determinant A adjoint A, and that is the answer. Question number 4. A equals 2, 3, 1 minus 6. B equals minus 1, 4, 1 minus 2. We need to verify that adjoint of AB equals adjoint of B into adjoint of A. First, we shall find out the LHS. AB is my first step. How to multiply two matrices? Row by column. First row by first column. 2, 3, minus 1, 1. So we are multiplying like this way. 2 into minus 1, 3 into 1. First row by second column. 2 4s are 8, 3 into minus 2, 6. Second row by first column. 1 into minus 1, minus 6 into 1. Second row by second column. 1 into 4, minus 6 into minus 2. Simplify the answer. As we write the answer, write adjoint of AB. What is the procedure for adjoint? We write interchange the main diagonal 16, 1. The other diagonal change the symbol minus 2, 7. So this is our LHS. Now we proceed to find the RHS. Find adjoint of B. How to write adjoint of B? B matrix, interchange the main diagonal minus 2, minus 1. The other diagonal change the symbol minus 4, minus 1. Now I need adjoint of A. A matrix, interchange the main diagonal minus 6, 2. Change the sign of the other diagonal minus 3, minus 1. I need to find adjoint of B into adjoint of A. That is minus 2, minus 4, minus 1, minus 1 into minus 6, minus 3, minus 1, 2. How do you multiply? Row by column. Minus 2 into minus 6, minus 4 into minus 1. First row by second column. Minus 2 into minus 3, minus 4 into 2. Second row by first column. Minus 1 into minus 6, minus 1 into minus 1. Second row by second column. Minus 1 into minus 3, minus 1 into 2. Simplify the answer. We get 16, minus 2, 7, 1 and call this as 2. Now we verify both are equal. So we will take and write 1, 2 implies adjoint of AB equals to adjoint of B into adjoint of A is verified, and that is the problem. A very simple problem, may come under 2 or 3 marks. Question number 9. A, B are given. We need to verify that AB the whole inverse is B inverse, A inverse. First we shall find out A inverse. The step is determinant A. 3, 7, 2, 5. What is determinant A? Multiply. 3 5s are 15, minus 2 7s are 14. So determinant A equals 1, which is not equal to 0. Therefore, A inverse exists. This is my first step. Write down adjoint of A. What is adjoint of A? Interchange the main diagonal. 5, 3. The other diagonal change the symbol minus 7, minus 2. The next step is write A inverse. What is A inverse formula? 1 by determinant A adjoint of A. So A inverse is equal to 1 by determinant A is 1, adjoint is 5 minus 7 minus 2, 3. So we have completed what is A inverse. We will proceed with B inverse. How to find out B inverse? The first step, determinant B. 6, 8, 7, 9. Determinant B equals 6 9s are 54 minus 7 8s are 56. So determinant B equals to 54 minus 56, that is minus 2. The same idea, determinant not equal to 0, inverse exists. So now we have to write adjoint of B. How to write the adjoint? Interchange the main diagonal 9, 6. The other diagonal, change the symbol minus 8, minus 7. And now I need to write B inverse 1 by determinant B adjoint 9 minus 8 minus 7, 6. My next step is to find out B inverse A inverse. B inverse 9 minus 8 minus 7, 6 with 1 by minus 2 out. A inverse is 5 minus 7 minus 2, 3. How do we multiply? Row by column, minus 1 by 2 into 9 5s are 45, 8 into 2, 16. Row by column, 9 into minus 7 minus 63, minus 8 into 3 minus 24. First row by first column, first row by second column. The second row by first column, minus 7 into 5, 6 into minus 2. Second row by second column, minus 7 into minus 7 plus 6 3s are 18. Simplify the answer. It is minus 1 by 2 into 45 plus 16, 61. Minus 63 minus 24 minus 87 minus 35 minus 12 minus 47, 49 plus 18, 67. So this is B inverse A inverse, that is RHS. So I call this as number 2. We will find out what is the LHS. To find LHS, I need to find AB. What is A? 3, 7, 2, 5. And what is B? 6, 8, 7, 9. How do I multiply? First row by first column, 18 plus 49. First row by second column, 24 plus 63. Second row by first column, 12 plus 35. Second row by second column, 16 plus 45. So AB reduces to 67, 87, 47, 61. The next step, we need to find determinant AB. 67 into 61 minus 87 into 47. You can use calculator, multiply and write. As we subtract, determinant AB is minus 2, which is not equal to 0. So I can write adjoint of AB. Adjoint, interchange the main diagonal. The other diagonal, change the symbol. And now I am going to write AB the whole inverse, which is nothing but 1 by minus 2, 61 minus 87 minus 47, 67. Minus symbol we treat it in the numerator, minus 1 by 2, 61 minus 87 minus 47, 67. Call this as number 1. Now 1 and 2 tells me they are the same. So LHS equals to RHS. So we will take and write the answer. 1 and 2 imply AB, the whole inverse is equal to B inverse A inverse, and hence we have verified the result.